Well, hello everyone. This is going to be a solution to question 15 from section 7.1 of your homework, which is essentially questions involving using integration by parts. And the one we're going to look at is this rather ugly inverse tan one. I'm going to begin by choosing the f and the g. In this case, since it's a single function, the f will be the inverse 1 over x, and the g will be 1. And that's pretty standard if you're trying to integrate a single function using integration by parts technique. Now, you want to integrate 1, you get x, so capital G of x is 1. And we also need to differentiate f, and that's a little bit trickier because what we're really looking at here is a chain rule. So it's the inverse tan of something. So when you differentiate an inverse tan, you get 1 plus that something squared times the derivative of 1 over x, which is negative 1 over x squared. Now we'll work on making this a little bit prettier. If you multiply the two numerators together, and if you multiply both of these by x squared times 1 gets x squared. And this is 1 over x squared times an x squared, so you get plus 1. Capital G of x, the integral of 1 is x. So we can now put the pieces together. I'm not going to bother about the limits of integration, we'll do that later. We'll just focus on integration right now. So we have this fella, and he's going to be f of x, capital G of x, take away the integral of f dashed x, capital G of x, d of x. So we do a bit of plugging and chugging. F of x is the inverse tan, 1 over x, times capital G of x, which is x. Take away the integral of the derivative, which is this guy, f dashed of x, times capital G of x. Now I'll do a little bit of style points here, make it look pretty. Rearrange the order for that term. Two negatives make a plus, and put this together. And so we're now at that stage. And I hope you realize that to integrate this, we have to change technique. And the technique we're going to use is called the U-sub. So the process then is choose your U-sub, which is that. Differentiate with respect to x, which gets you 2x. Do the crossover. And then divide both sides by 1 over 2x to isolate the dx. So our question is going to turn into x inverse tan of 1 over x plus the integral of x over u times 1 over 2x du. And that simplifies down to 1/2 1 over u du. We'll now integrate. And if you integrate this, you get 1/2 the natural log of u. If this was an indefinite integral, I'd do a plus c, but this is a definite integral, so I'm going to leave that blank. But what I am going to do is to return everything back to x's. Now, because I've done that, I can now put in the limits of integration. So it's going to be from x equals 1 to x equals square root 3. And at this point, it's really just a matter of putting these values in and simplifying them as much as possible. So let's see what we get. It's going to be square root of 3 first. So it's going to be square root of 3, the inverse tan of 1 over the square root of 3 plus 1/2 the natural log. Square root of 3 plus 1 basically becomes 4, and you've got that guy. So that's your first one. Take away. Now we'll put in 1. And what we get here is 1 inverse tan of 1. So that's just the inverse tan of 1. Plus 1/2, 1 squared plus 1. So 1/2 the natural log of 2. And this becomes square root of 3. And I'll just do a quick check on what the inverse tan of 1 over root 3 is. And it happens to be pi over 6. And this fella here is going to be a 1/2 log 4. Take away the inverse tan of 1, it's pi over 4. And this fella here, I'm just going to leave him, is negative 1/2 log 2. So this fella is pi root 3 over 6. This guy here is minus pi over 4. These two guys here can be rewritten as a natural log of 4, take away the natural log of 2, if you pull out a common factor of 1/2. So we have this term, take away this term, and a log of 4, take away a log of 2, it's 4 divided by 2, which is 2, so you end up with plus 1/2 the log of 2, and that guy is the answer to our definite integral.